This is the beginning of section 6.7, and the objective is about solving applied problems involving the Pythagorean theorem and powers and roots. So that is all the applications of powers and roots. And you've probably heard of the Pythagorean theorem, a squared plus b squared plus c squared for a right triangle, where the right angle is between legs a and b and the hypotenuse is c. And that's actually thousands of years old, and Pythagoras perhaps was not the first one to come across it. The Egyptians used it thousands of years ago, that after the flooding by the Nile, they reestablished their fields where they grew whatever they grew, cotton, whatever. And so they used that to establish rectangular fields. So, of course, the pyramids, they use the principles that we see expressed in the Pythagorean theorem. So there are many different applications of it. So we'll be looking at this here at some examples. And the first one is example 1. Find the length of the hypotenuse of this right triangle. Give an exact answer and an approximation to 3 decimal places. So from the a squared plus b squared equals c squared, we get 4 squared plus 5 squared equals c squared, or 16 plus 25 equals c squared. So then c, 41 equals c squared. So then c is the square root of 41. And the approximation to 3 decimals for c is equal to 6.403. 6.403. So that's an approximation. Applying the Pythagorean theorem to exercise number 2 would be 1 squared plus b squared equals the square root of 7 squared. So 1 squared, of course, is 1 plus b squared, and the square root of 7 squared is equal to 7. So then b squared is equal to 6, or b is equal to the square root of 6. And then to 3 decimals, b is approximately equal to 2.449. 2.449. So that's the approximation. This is the exact answer. This is the approximation. The next exercise is about a baseball diamond. A baseball diamond is actually in the shape of a square, 90 feet on a side. Suppose that a catcher fields a bunt along the third baseline 10 feet from home plate. How far is the catcher's throw to first base? Give an exact answer and an approximation to 3 decimal places. Well, let's draw a picture here, what a baseball diamond looks like. And so I'm just going to draw it as a square, because that's really what it is. So each side is 90 feet long. And so let's say this is home, this is first base, this is second base, and this is third base. So we are told that a catcher fields a bunt 10 feet from home plate. So this distance is 10 feet here, so 10 feet here. And we know that this length here is 90 feet. 90 feet and 10 feet. And so the question is, what is the distance from here to first base? In other words, these are the legs of our right triangle, and this would be the hypotenuse C. So in other words, we have 10 squared plus 90 squared equals C squared. Or, in other words, C, so it would be 100 plus 8100 equals C squared, or C squared equals 8200. And then C, the exact answer is C is equal to the square root of 8200. And so that distance is in feet. And in the 3 decimal approximation, so C is approximately equal to 90.554 feet. So the one with the square root is the exact answer. And then here we have the approximation to 3 decimal places. You've probably seen letters painted on a road for messages. And so they found out in a psychological study that the ideal length of the letters of a word painted on a pavement is given by this expression. L equals 0.000169 d to the 2.27th power divided by h, where d is a distance of a car from the lettering and h is the height of the eye above the road. And all units are in feet. And it turns out for a person h feet above the road, a message d feet away will be the most readable if the length of the letter is L. So here we're going to go for the question, find L given that h is equal to 3 feet and d is equal to 180 feet. So L equals 0.00169 times d equals 180, so the 2.27th power divided by h, and h is equal to 3 feet, so divided by 3. So we evaluate this expression by raising 180 to the 2.27th power, and so you can use your scientific calculator, it has exponentiation, and so the iPhones have an exponentiation key, and I think the Android phones also. Then we multiply that result by 0.000169 and then divide it by 3, and the result is that that's approximately equal to 7.4 feet. So that would be the answer. So what we've learned in this chapter so far has some applications, and you saw one out of literally hundreds and thousands. And this concludes section 6.7.